Great, and hello, good afternoon, good morning to everybody joining this panel. The panel is titled Reimagining AI in Education, Perspectives from the Institute for Student AI Teaming. And this panel will be focusing on highlighting sort of a new vision for AI that sort of moves beyond the cold autonomous agent working for humans to becoming more of a socio-technical synergistic partnership with humans. And so the Institute, we will go through some different people here talking about how the different approaches can come together to enable this vision. And so the first speaker for this will be Sidney DMello, who will give an overview.
See my you can see my Hey guys, good to be here. I actually gave a talk at this conference about December 2020 when we just launched our institute about 2 years ago. We didn't have much to talk about, but hopefully we got a lot to share with you today. So I'm going to just start with a quick 3 or 4 minute overview of the institute. Then I'll hand it over to our very talented colleagues to talk about different phases of our research, just to give you a little sampling. And then we'll end with, I'll kind of bring it back together at the end, and then we'll have a discussion. Next slide. So we're a very large and exciting team here at CU Boulder, as well as with 8 other institutions across the country. And we have partners in school districts and so on. We're kind of asking a very basic question of how to promote deep conceptual learning through these rich socio-collaborative learning experiences for all students. When we were starting this institute, we were thinking a little bit about what is it that we want to do that's a little different, not necessarily better, just different from the past work in AI and ed, which is about 50 plus years old. And in thinking through, we also said, hey, what's exciting us and what are the important problems? We kind of identified 3. One is enhancing the bandwidth of communication from unimodal one-on-one systems to naturalistic, multimodal, multi-party social interactions. We're really excited about doing this in the classroom too. So there's a lot of great, exciting technical challenges there, as well as, kind of looking at more interesting dynamics of small group interactions. The second is this realization that there is not enough time to just say that a math class is math and an English class is English and history is history. And we just think that if you look at the great problems facing society today, we need to start training the next generation of youth, which what I like to call building the whole student. And the idea is that as they're learning some fundamental competencies such as math, literacy, science, or whatever, at the same time, they're developing some critical 21st century skills of argumentation and critical thinking and computational thinking and collaboration, while also developing intrapersonal skills such as persistence and how to handle challenge and so on. So in thinking about our institute, we try to think about how can we develop curricula and technology that supports multiple dimensions. And lastly, this idea of, gone are the days where we can develop technology and not worry about its consequences because AI is too bad and too old and it'll never have any effect. But now we've learned that we can't just have these things as afterthoughts. And another opportunity here is to really reimagine what is ethical and equitable AI. And I would say going beyond ethics and equity, but also towards a lens towards AI justice. Next slide. So very briefly, putting these 3 ideas together, opportunity 1 is we're thinking about AI as the social collaborative partner that kind of is embedded in small groups of students, small groups, helping them along, keeping the conversation going, while at the same time, coordinating and collaborating with the teacher. And this is where the bandwidth of communication now is purely fully open social interaction. Next slide. Very briefly, we're looking at curriculum. We're actually focusing on promoting AI education or AI literacy because we think that's very critical for the future generation and the future workforce, but doing it in a way that's embedded in STEM content while also using curriculum that's rich on inquiry learning and other 21st century skills. And lastly, we are adopting a framework of responsible innovation to really think about our institute as how does a team of diverse people come together to develop technology for the classrooms in an ethical and responsible way. And what is a framework to guide us? And this framework of responsible innovation, we find it very helpful to help us think through every decision and also look back. So one of the dimensions of this framework is reflexivity, when we hold the mirror back to ourselves and say, are we living up to our ideals? Where should we be doing things differently? So what we have for you today is just a sampling of research in each of these three areas. Our institute is organized based on three research strands, starting with foundational research, which is about understanding and facilitating collaborations, basic AI stuff. Work in the learning sciences, which is how do you broaden in participation with co-design and curriculum design and so on. And lastly, in the middle is kind of more like computer-supported collaborative learning and team science. We'll just feature researchers from each of these areas. So next slide. So we're going to start with Michael Chang, who's a postdoc here at Berkeley, working with the Institute, and he's going to talk to you about Learning Futures workshops. How this is one of the ways we're instrumenting the responsible innovation framework.
Thank you. Oops, can we go back a slide, please? So hi, I'm Michael Allen Chang, and today I'll be talking about Learning Futures workshops. And the goal of these workshops is to surface youth's expansive dreams for classrooms and AI. So really excited to share these with you. Next slide, please. Yeah, so why youth voices? And just to kind of go back to what Sidney was talking about earlier, central to ISAS's work is this huge commitment towards responsible innovation. And there's four pillars for responsible innovation: anticipation, reflexivity, inclusiveness, and responsiveness. And we wanted to tackle the issues of anticipation and inclusiveness. So anticipation meaning asking what if questions about possible futures, and inclusiveness, bringing in folks into the design process who typically are excluded. My colleagues will kind of give you a sense of the reflexivity and responsiveness of our work in the later presentations. So who did we want to bring into the work? So we wanted to bring in students in particular, because students are especially impacted by the adoption of new technologies for classrooms, but also have historically been limited or have had limited or negligible input into the design of these technologies. Next slide, please. So this leads us towards what we're calling the Learning Futures Workshop. And the goal of the Learning Futures Workshops is to surface youth's expansive hopes and dreams around collaboration in schools, identify the role that AI has to play in making these a reality. So just wanted to sort of, oops, can you go back a slide, please? Just wanted to sort of emphasize 2 points in this. First, when we say expansive, we're really trying to push beyond the boundaries of how we expect schools to be and instruction in schools to look like, and also to push past sort of our expectations of how technology has to work. And secondly, I wanted to emphasize that in thinking about AI, we think of it as a tool towards making these ideal collaborations a reality. Next slide, please. So who was in our workshop? So we did an in-person workshop at UC Berkeley during spring break 2022, and we had 15 high school students. Recruitment, we had recruitment from local high schools in the California East Bay, and we were very intentional about who we asked to join us. We asked all youth of color, half are male identifying, half are female identifying, and we had no prerequisites for the workshop other than an interest in AI. Next slide, please. So just to give you a higher level overview of our workshop structure, we had 3 days, 7 hours a day. So the first day of the workshop, we started off by surfacing sort of expansive forms of collaboration that may not be experienced inside of classrooms. So where do you experience collaboration in the everyday? So in the bottom picture on the right side, you can see this graduate student cooperative house at UC Berkeley. So we took them in and they got a chance to learn about the ways that 70 really different people had to live together during COVID too. The second day of the workshop, we sort of took these expansive forms of everyday collaboration and then used them to inspire speculative, ideal collaborative spaces, and they had a chance to build them out using dollar store materials, which you can see on the top right of the top right picture. And finally, in day 3 of the workshop, we sort of brought it back into schools. So how do you experience collaboration inside schools today? And how are your AI designs from day 2, when they were building out their speculative spaces, compatible or not compatible with schools? Next slide, please. So I don't have that much time today, but I just wanted to share one of the sort of imagined speculative spaces that our youth dreamed up. So one group of youth imagined a collaborative world where comfort was front and center. And especially important to this issue of comfort was, how do you feel safe? And when there is conflict that's inevitable between people who are within the imagined world, how do you peacefully resolve this? And I wanted to highlight the key contested issue, which is, how do you create a safe space? And initially in this design process, young people sort of took from what we consider sort of dominant ideologies around creating the safe space with an authority that keeps everyone in line. But then young people started to recall their everyday experiences. They thought about the cooperative house and how people in the cooperative house, all 70 people, had a chance to collectively create a set of community agreements that dictated how they would share common space in the house. So using that as inspiration, young people instead shifted from authority towards accountability, towards collectively agreed upon community agreements. So this was a huge shift for the young people, and they thought about how technology could support that shift. Next slide, please. So I wanted to highlight what they called the magic fence, and that's in the red box here. And you can see on the fence, there's sort of a popsicle stick of each of a different color. And they imagined that each panel represents accountability to each agreed upon norm, and these magical fence would light up when people were sort of acting in accordance with these agreements. Next slide, please. So the next day in the workshop, we're like, okay, you have these speculative spaces. How do you turn them into something that might be more feasible? And they imagined this device called Live, Love, Light, which is shown in the picture on the left. And each of these sort of test tubes, it's situated in this sort of conflict environment, and they agree upon these norms about how we shouldn't behave in conflict. So they didn't want curse words in conflict, they didn't want slurs, they didn't want loud volumes, they didn't want shouting. And if any of those things happened, these would light up with each of these test tubes. Okay, so we have this in this imagined space. How do we bring them back into schools? So youth called this, just to take a step back, the youth called that device Live, Love, Light. And youth saw possibilities for Live, Love, Light inside classrooms. For instance, recognizing emotions and helping them know when other classmates are upset, maybe they missed it. Another place where they imagined it was in restorative justice circles, when they were interacting with teachers who had caused harm to them. The youth were very careful to let us know that while the Live, Love, Light would be helpful, it would largely be insufficient in the face of deeper institutional issues. Why were the teachers causing them that harm in the first place? And why wasn't the school doing anything about it? Technology is part of the solution, but not solving the bigger picture issue here. Next slide. Great, so I just wanted to summarize some of our key findings and conclusions. One, in dreaming about ideal collaborative spaces, youth highlighted the importance of practice and technologies that supported them in forming relationships with each other during collaboration. Secondly, we demonstrate how our approach of experiencing expansive forms of collaboration, creation of speculative spaces, and exploring these tensions of bringing these ideas into real classrooms are generative towards these expansive ideas around how technology can support ideal collaborations. And finally, when thinking expansively, when given this chance to do so, young people dreamed of broader institutional change and being taken seriously by school administrators. And I think one thing to just leave on is, how should future AI-based projects take on this critical dream? Is this the role of AI at all? But just some food for thought as we sort of close up with this particular presentation. Next slide. And we have some additional papers if you're more curious about our work, and feel free to reach out if you have more questions. Thanks.
Good.
Okay, I think our camera might have died, but I think people can still hear me.
Yes, I can hear you, Peter.
Okay, thank you. So I'm Jason Reitman. I'm a postdoc here at ISAT. I focus a lot on our classroom data collection and analysis. We're going to swap seats really quickly and maybe camera will work.
What's up?
Turn on your.
The camera's on.
Okay, there we go. Sorry about that, folks. I focus on our classroom data collection and analysis, mostly on speech annotation. Next slide, please. And when I say classroom data collection, I really mean we are collecting data from the context that we're thinking about designing for, right? So we have these curricula that are implemented in public school classrooms where students work collaboratively a lot of the time in small groups and dyads, and also sometimes individually, all around these specific anchoring routines. In this particular example, the sensor immersion curriculum, they're learning about how sensors and data displays can answer different questions that they might have. So they start with a pretty broad question in lesson 1, and as they progress, they each become experts in some facet of that lesson plan, and they come together and work together on problems that first they're presented with, and then they come up with. And I'm going to be quiet for a second so you can see exactly what I mean when we're talking about our data collection with this video. Sorry, one sec. We'll restart that video in a second.
Images have been narrated.
Okay, so what we're seeing here are small groups of students who are sorting these cards, right? So they have to decide what category each card sort of fits into. And this is just one task in that lesson plan. And here they're doing pair programming, so now they're in dyads, and they're each given a particular role. So there's a driver and a navigator, or pilot and navigator. And the driver is in charge of actually interacting with the computer and interacting with the code, and the navigator is sort of guiding them along and giving input. So you can see there's a lot of multimodal collection we need to do with gestures, with speech, with the artifacts that they're actually interacting with. Here's an example of when they're actually using physical artifacts in their lessons. Again, in dyads, so working together to figure out how to make this thing work. Next slide, please. And one more. Okay. So we have this data pipeline, right, where we have these curricula implemented in schools that are built out of these collaborative tasks. We go into these classrooms that are working with these curricula, and we collect video, audio, the physical artifacts they're working with when they're actually doing the collaborative work. From there, we have automated speech recognition. We'll take that audio and turn it into transcripts that we can then, as researchers, annotate. And those annotations, which we have various schemes that I'll talk about in a second, those annotations are what drive the computational models we design. Next slide, please. So when I say annotations, we really have a whole slew of different ways we process these data, but I'm going to focus specifically on a few ways that we're processing speech. So those actual automated transcripts. Next slide, please. The ones I'll focus on are collaborative problem solving, academically productive talk, and team communication. And each of these come from a slightly different approach, and I'll talk about that in a second. But it's been really powerful to take these different approaches and see where they converge and what they each bring uniquely to sort of get at some of these underlying dimensions of collaboration. Next slide, please. With collaborative problem solving, it's really built around these three main facets of collaboration: constructing shared knowledge, negotiating or coordinating, and maintaining team function. And each of these are further broken down into subfacets that you'll see in a second, and indicators that are actually the level that annotators work at. But it's really built to surface these three main facets of collaboration. Next, please. In academically productive talk, it's built around these talk moves, which are sort of different ways or strategies that students can speak, that students can use to talk to each other, that are sort of known to instigate collaborative behaviors. So whether they're relating to each other in their speech, whether they're asking for more information or making a claim or providing reasoning for those claims. Next slide, please. And then team communication is focused largely on different styles of communication, whether they're being motivational, whether they're sharing information, whether they're talking about things in a timely manner as they're happening, and whether they're sort of talking about their group as a collective as opposed to as individuals. Next slide, please. So we can use these different schemes in different ways. First, we can look at them individually, right? So if we want to deep dive into APT, for example, we can see what sort of collaboration skills are being used and aren't. So if we look at relating to another student or making a claim, across these 31 observations, you can see there's a healthy spread of how much students in these groups are actually using these skills. But asking for more information isn't happening a whole lot, and providing evidence or reasoning really barely happens at all. So those are places we've identified that, you know, we might be able to encourage more to have a larger impact. And next slide, please. When we take a broader view and look across these schemes, we can look at how schemes are loading onto each other or how they relate to one another. So this is an example using team communication and collaborative problem solving, where the way you would read this is, for example, in that motivational graph in the top left, if we code something as motivationally positive, we're also 24.5-ish more times likely to also code it as advancing the collaboration process. So you can see here that, for example, informative aligns really well with these CPS subfacets. But something like motivational, you can see it's bringing something unique in that it is only really relevant or associated with one subfacet from CPS where you're advancing the collaboration process, but maybe they're not talking motivationally positively when they're responding to each other. And next slide, please. So the big point I want to make here is that these annotations are being used in a few ways. We're starting to understand these underlying dimensions of collaboration across these schemes. We're also producing data that are useful for the whole institute and even beyond that, where we have software engineers, learning scientists, team scientists, and others who can really make use of this. And finally, these are the actual sort of ground truth data that we're using to drive the computational models we're building AI with. Thank you.
Hi, I'm Rosie, and I'm just going to tell you about some of the technical challenges that we face with working with audio in the classroom. Next slide, please. So speech is just one of the many inputs we can use to look at collaboration, but that's what I'm going to focus on. We want to know both what is being said, so that's automatic speech recognition, I'll refer to that as ASR. And there's also speaker diarization, so who is speaking when, and of course that in itself tells us a lot about collaboration. And as Jason already alluded to, this speech recognition, this automatic speech recognition provides the transcripts to help speed up this process of annotating collaborative problem-solving schemes and other schemes. But also, we need accurate transcription in order to be able to then have these natural language understanding models which can track multi-party collaboration in the classroom. Next slide, please. So this is just an overview of the speech processing that we have in place. So if you recall from the video, we have like a microphone sat on the desktop of each group. So it's just one channel of audio for an entire group. And there may well be multiple different tables within the classroom. So first we have to extract utterances from the audio. So either just based on sort of naive, is someone speaking or not, or we can do that in a little more complex way I'll go into later, where we extract a target speaker. And then we transcribe the speech, and there are two different ways we could do this. We have looked into using widely available cloud-based providers like Google. The benefit of this is that they are low cost and they're well documented, so they're quite easy to incorporate into software. And these models will often be refined and updated as well. However, this doesn't necessarily work great, as I will go into in future slides. We are also experimenting with training our own models, which we can host locally and fine-tune using the human transcripts that we do have for some of for a subset of the recordings. Next slide, please. So what are the present challenges? So these cloud-based APIs, such as Google, they do really well at transcribing adult speech. They do really well in maybe a situation like a meeting where one person speaks at a time, or in a Zoom call where your microphone is going to be very close to the speaker. It performs a lot worse in the classroom. And these models are typically trained on adult speech. They're typically trained on quiet speech as well. So we have this domain mismatch. So in the classroom, we have a lot of competing speech. We have a lot of ambient noise. The speakers are quite far from the microphone. And then you've also got differences in the way children speak, both in terms of acoustic features and in terms of the language that they use. So our goal is to train our own systems using our own annotated transcribed data that humans have transcribed. This is a work in progress, as we have very little training data. But fortunately, with new deep learning approaches in speech recognition, it makes it possible to take an existing model that has been trained on a huge amount of adult speech and then fine-tune it using just a small amount of labeled audio from your domain of interest. Next slide, please. So just to show you some actual examples of this, here's just a tiny excerpt from a dialogue among several students. We have the human transcripts and then 3 different providers we looked at: Google and Watson for the cloud-based services, and then more recently we've run this through Whisper, which is a newly available model that you can run yourself. So we have these various different types of error that we can see. We have, at the word level, we have deletions, we have substitutions, and we have insertions. The first thing that jumps out is just how high these word error rates are. They're between 70 and 90%. So 70 and 90% of the words are incorrect. But there is kind of a difference across services of, whether it favors insertions, like Whisper tends to kind of repeat certain phrases, or deletions where Watson might just leave out 90% of the words in a given utterance. Yeah, so basically all of these are performed pretty poorly. Next slide, please. But we did want to see just how bad of an impact this might have on our downstream NLU tasks. So not all of these errors are going to have the same impact. So you might have a word transcribed incorrectly that doesn't actually contribute a huge amount to the meaning of the utterance. And so that might not be a very impactful error, or you might have a key content word that is just completely missed. And, if you try and detect a CPS facet from that, it's just going to struggle. So we computed various downstream measures that tried to capture different levels of abstraction of meaning from the transcript. So in increasing order of abstraction, we have this blur score, which is like a word overlap score, very similar to a word error rate, but just doesn't rely on word order. Then we looked at a measure which we call topic distance, which is, sorry, I should have said, when I say distance here, I'm talking about the difference between a metric on the human transcript versus an ASR transcript. So the higher this distance measure, the worse the ASR does at capturing the meaning at that level. So yes, topic distance is particular content words derived from the curriculum. Then we have semantic distance, which is looking at sort of embeddings of sentences in sort of low dimensional space. And then finally, we have something which is more domain relevant. This is a CPS model, which detects the probability of the three main CPS facets that Jason showed you before. And we fit a mixed effects model to see how the different kinds of ASR error impacted on these downstream measures. We didn't have many insertions, so none of those came out significant, but both substitutions and deletions did impact downstream measures. However, tentatively reassuring for us is that for each standard deviation change in increase in error rate in the ASR, we only get half a standard deviation increase in error at the CPS level. So it seems that maybe the more abstract you go, the less impact these individual word errors will have on your downstream measures. Next slide, please. And then a second way that we analyze the audio is to detect who is speaking. So one way we might be able to improve the quality of our transcription, as well as to get useful information on how the discourse is proceeding between multiple speakers, is to be able to label in time, like who is speaking when. We can remove background speech that's from students that we're not necessarily interested in transcribing. So we have the children enroll at the start of the curriculum unit, where they just speak like 20 seconds into the microphone so that we can capture a known sample of their speech. And we can use this to then detect future samples, detect which person is most likely to be speaking. So in the table at the bottom left there, we have this simple target, non-target filter. And at the moment, there's this kind of trade-off where you can set a threshold depending on how important it is to definitely reject non-target speech versus definitely not reject too much target speech. So at the moment, these rates aren't perfect, but it does seem to help with the ASL quality. And then looking at actual speaker ID, at the moment, the error rate is about 40% on our classroom audio. Although looking at a separate data set where we have clean speech from children who had like a headset microphone, it's only 13% this error rate. So it seems a lot of it is to do with this noisy classroom environment more than children's speech per se. So we do hope to see improvements by retraining this embedding model, by adding in background noise and reverb. And experiments on this are underway, but still so far we see the best results with the pre-trained model. This might actually be a case where the low-tech solution of getting better audio quality in the first place is really going to help. So one thing we're looking into now is to use individual microphones on individual students. That's all from me. But yeah, if anyone has any questions, I see actually there is one now. Google Pixel will incorporate live transcription in their recording app along with annotation of who's speaking what. Yes, there's definitely an explosion of really exciting tools. So yeah, thanks for bringing that up. I don't think we've looked into that one. I'll hand over to Sidney.
Well, thank you, Michael, Rosie, and Jason. I just wanted to just kind of wrap up and try to connect up some of the pieces. So we have been working on our first version of the AI partner. We have several. This one's called a community builder, and it's kind of when we're thinking about these AI partners, we're kind of thinking of them as a suite of things, not just like one talking head or one physical thing, but a collection of, shall we say, partners that facilitate the exchange of information between students, teachers, and AI. And we're thinking about them interacting in different ways. So you can imagine the scenario of many small groups. And one of the types of partners is what we call a collaborative co-pilot that kind of works with individual student groups kind of helps them. It may have some dialogue components and so on, but it's very much task focused. And then we have this idea of an augmenter, which really is distilling information and nuggets of information from these different groups that gets fed into the teacher. For example, what are the topics that are really exciting you? Can that be used for subsequent whole class discussion and so on and so forth? And lastly, we have this idea of the community builder, which I want to talk to you about today, which is really about helping youth attending to the relational aspects of collaboration. So not just the task and content aspects, about helping students have better relationships with each other and better ways of collaborating. Next slide. So this directly came from this Live, Love, Life device. It was inspired directly through that. And just as a reminder, the idea is to change the conversation from AI teachers or adults policing youth to about the youth themselves coming up with mutually held agreements of behavior and then holding each other accountable. And this directly came from that cooperative house that Michael mentioned. So in our design, we've been thinking about different ways in which we could do this. And the basic idea is that students and teachers collaboratively come up with what are the norms or agreements of behavior that they value, such as being respectful, having equitable interactions, advancing the thinking forward, building a learning community. They then note down indicators of those behaviors, such as being nice to each other and so on. And then the AI listens in on those conversations and tries to find evidence of those indicators and brings it to their attention in a form of noticings. And the idea is not that it gets it right or gets it right all the time. The idea is that this inspires some conversations about what's actually occurring. And that AI, we've called it a community builder. Next slide. And there's many different dimensions and things to think about. So in one design, you can think about this is more of a quantitative design where you're actually giving feedback. And this is at the whole class level, I should add. So we're not calling out individual students. Privacy is really important here. So it's very anonymous, but this is at the whole class level. And these are the 4 norms. This is a very quantitative kind of version of giving feedback. Everybody wants to see numbers, but there are some risks there. The numbers are gameable, and they could be demotivating and so on. So another design is more of a qualitative design, where these are, again, very early stages of design, but you can actually think about these spaces or multidimensional space. And instead of saying your respect score is 70%, it actually shows examples of each of these smiley faces is one exemplar. And so if you click on it, it could be something like, that was a great idea. Thank you so much. This is why I thought these were respectful. But then the students and teachers can have a conversation and push back and say, hey, I actually think that was equitable. I don't think this was respectful. And we think about respect in this way. Why is Kobe, the community builder, thinking about it in that way? And so the hope is that this will lead to some good conversations and discussions, and over time, a shift in some of these behaviors. Next slide. And I want to say that underlying all of this is what we call a different form of conjecture maps that Michael here has really been instrumental in pushing us thinking this way. But it's really a theoretical, very intentional deep dive from back end of what the code can do to front end decisions, to mediating processes, to outcomes, and different pathways that offer testable hypotheses that we're actually hoping to test out in the classroom in this spring. Now, lastly, I'll just end by saying there's a lot of technical challenges we need to address, and we've made a decent progress. Here's a quick video just showing you what we can compute right now through ISET. This is a researcher view. It's not intended for students and teachers, and I hope you can hear the sound, but it just takes you through some of our technology.
At the NSF AI Institute for Student AI Teaming, we have developed a speech-based AI display for small group collaboration in classrooms. We are an interdisciplinary community dedicated to transforming classrooms into more effective, engaging, and equitable learning environments through developing and refining AI technologies. Here we highlight what we can currently sense in the classroom in the form of a researcher display. We currently display data on student groups at multiple levels, including acoustics, conversation, content, and collaboration. The specific metrics include the signal-to-noise ratio, the number of words spoken, and the words themselves via automatic speech recognition, degree of topic and task-related talk, and collaborative problem-solving metrics, including building knowledge, negotiating, coordinating, and team function. We can also explore the raw JSON output that is generated by the AI pipeline, which includes each utterance and diarization of who said it. We will now show the display running with 7 groups in the classroom.
And then you have a try to do it like this. Or you could finish.
Like, why is nothing like, did we do something that right? Maybe, I think the thing we probably did was we didn't plug something in the right place on the code.
I finally figured out because I had to use hands. And then we figured it out. But Kimmy, can you frame into this?
Finally, we consider student privacy and agency critically in our designs. For example, students can turn off the sensors when they want some privacy. Overall, this technology is a key step towards providing AI tools to support student collaboration and teacher orchestration in classrooms.
Well, thank you. So that'll wrap it up for us. Just leave some time for discussion and conversation. I'll hand it over to Peter. But yeah, this just give you a sense of some of the work we're doing, and really excited to work and collaborate with you all.
Great, thank you, Sidney. And so now we're going to turn over to discussion. So if you have questions, and I already see some questions coming up in the chat and the Q&A, and so you can either put them in the Zoom or in the Whova Q&A, and I will run through them. Before we do that discussion, I just wanted to point out that one of the things about this institute is to be able to serve as a nexus point for people working on collaboration. And so one of the things we really want to do is to try to bring together people very broadly in learning sciences, team cognition, machine learning, AI, multimodal processing, inclusive design, and education, and sort of look at how do we work on these theories and methods, how do we build these analytical tools, how we think about AI and ethics in here, and also how do we develop, and also how do we share data sets. And so part of this, I want to just conclude this before we go into the discussion to just talk about how do we we want to keep on sharing with all of you and start collaborating with you, because in order to study collaboration, we really need to have good, diverse collaboration. And so we want to be able to have collaboration. And so with that, what I'm going to do is to move into the chat and address any questions. Feel free to put in questions that are coming up. I'll start with the first one, just ask the panel on this. What are the considerations for reducing the intrusiveness of multimodal data collection in classrooms in ISAT?
Yeah, thank you. Can you turn this on? It might be working. So great question, Ahmed. Good to see you again. How are you? We're on a project together. Basically, the idea was that one thing we started to do from the ground up is not say, hey, we're going to make a smart classroom that costs $5,000, $10,000. We're already starting to work with very commodity sensors, and essentially just a $100 microphone, which we could even get cheaper, hopefully, and just the camera on students' own Chromebooks. That's what we are right now, or with maybe an iPad camera. But the idea is to see how far we can get with speech. But then the thing about this curriculum is that it's very, very gesture focused. They're playing with sensors, they're moving things around here and there. So I just don't know if we can actually make sense of the situation without having some other modality in there. But of course, we want this to be robust. So if kids want to turn off their cameras, it should still have some basic level of functionality. So, but other than camera and microphone, we're not really looking for much else. No physiological sensors or connects or anything like that. We got this other camera working, so that's nice.
I think just one thing I'd add to that is that a lot of these classrooms have either Chromebooks or iPads already in use for their lesson plans. So really just being able to use that technology that they already have cuts down a lot on how intrusive it feels.
One thing to add on my side as well is in the learning features workshops, we talked some about data privacy. And the young people encouraged them not only to think about what data is being collected, so not just transcripts and video, but also what was being done with that data. That in and of itself is more invasive, has potential to be more invasive because you can learn things that are, way more invasive than the precise movements or things you're saying inside the classroom.
Great, thank you, panel. So another question, and I want to encourage others to submit any questions that you have. So another question that's coming from Uva is really sort of talking about this challenge of measuring and giving feedback in a timely fashion. So I want to sort of see what the panel thinks about both timely measurement and what you think about timeliness in terms of feedback.
I think we're still figuring out when the right time to give feedback is, but that video at the end with the demo of the live workings of some of these, computations we're doing is a really good example of how immediately we can at least measure at this point and eventually give feedback. And there are some things that you don't want to immediately prod. You want to let them sit there and figure out for themselves. So it's sort of an active question that we're thinking about.
Yeah, I would just add that the view of the classroom that I find exciting is a bunch of kids talking to each other and doing learning, thinking and doing and playing with artifacts, but really talking. And I don't care about the AI that much. I don't want it ruining that basic interaction and dynamic. Also of a teacher that's coming around and checking in on student groups. The questions for us are, how do we embed AI in this already exciting dynamic that's occurring in a way that's not distracting? So for example, having a teacher with a dashboard on what the different students are doing, they have no interest in that. In real time, because they're already busy and they're doing 1,000 things and they have their own system. But being able to give them information on where they're not omnipresent, on the conversations, that's something they value, but they don't necessarily need it in real time. Secondly, giving feedback and collaboration when thinking that may happen as an after action review after the whole class, and building those into routines that occur after every class. So we're really thinking very carefully as how to not have the tech be intrusive and interfere with what I call the most exciting thing, which are a bunch of people talking to each other.
Rosie, just to add one last thing, as was mentioned in Sidney's talk, one of the really cool things about this institute is that we get to work with really experienced curriculum designers. And I'm no curriculum designer expert myself. What I learned from them is this ebb and flow that sort of happens over the course of what they've termed a storyline unit. And I think what that sort of helps me see, at least, is that there's sort of these expansive moments during the curriculum where you're supposed to generate all kinds of ideas. There's also convergence moments where you want to sort of arrive at one idea for the whole class to explore. And I think when we think about feedback, thinking about that embedded within these sort of contexts might give us clues as to whether we want sort of real-time feedback, or also what kind of feedback we want to give perhaps at the end of the discussion. So the fact that we're sort of coupling these two areas of research, I think helps us to inform that question.
Okay, so thank you. Another question that's come in is sort of more, it was asking specifically about OpenAI's GPT-3 language model, but let me just sort of make it more general a little bit about sort of how do you deal with some of the integrity issues of sort of larger hidden language models if you're processing language and factor in issues of explainability.
I think actually one of the strengths of how we're designing this is to be transparent in that it's not perfect, and it gives students something to talk about when it isn't perfect. And to me, it's honestly more important that we have a design and a lesson plan that has opportunities for talking about the imperfections and why it's imperfect than it is to be close to perfect at all.
Yeah, I'll just add on that, like 2 dimensions, I would say. The first thing is we're working with very diverse youth, and there are a lot of questions about the appropriateness of some of those large language models with these youth, starting with speech recognition all the way to everything else. We've just finally compiled a sufficient corpus to start investigating those questions of fairness and bias. So we're not there yet. But then the second thing, though, to Jason's point, is that actually our curriculum is AI literacy. And I showed you the sensor immersion one, but a whole another unit we're developing is on AI in games, and where students then actually are learning issues of bias and fairness in games, but at the same time, they're learning like basics of training language models, literally backpropagation and how all of that works. And we're hoping to use those examples and those opportunities to give them a nuanced picture into both the concerns of how these models work, but also what the strengths, weaknesses are. So it's a multifaceted approach, but I'll have more to report on that in the next 6 months.
Okay, great, thank you. So another question that's asked is, how do you navigate the consent process? Students, parents, schools, education systems. What have been your key ethic considerations with consent processes, particularly with regard to sharing of data sets beyond your project and researchers?
So right now, what we do, again, basically, just to clarify, every kid that we study right now, we have full parental consent, as well as student assent, all that for the short term. One of the big challenges that occurs is, of course, bystander challenges. When you're picking up on kids, and the teachers form groups, by the way, they form the small groups based on consented students. And we are doing some analyses to make sure that that's not selective in leaving people out and so on. But we do have concerns and issues come up when you have bystanders in the video and audio and what to do. And right now we've been extremely careful, and we just take everything out if we don't have consented students. And in fact, sometimes we wind up deleting a third of our data because of not being able to track down consent forms, because teachers collect them and they throw them out or whatever in the cars. With data sharing more broadly, we've actually been working on may have some breakthroughs there that Peter here has been an initiative he's been leading. So I'd like him to share what he's been doing there. Yeah.
Yeah. One of the things that we've been working on within this institute is to bring in the idea of a IRB approved repository, and a data repository is a model that comes out of the medicine side, where they collect large amounts of data on individual patients, but oftentimes when they run a study, it's only for doing it for one particular study. But if they can get people to consent into being part of a repository, then that data can be used for other purposes and shared anonymously in much broader ways. And much like in sort of these cases of medical model, where you might be measuring people's blood flow and a variety, the respiration and a lot of things for just one study on a particular type of cancer, but you might want to use it for other types of studies later. If you can get people to consent into these repositories, it can be set up in a way that it can be shared and for people who have the right level of IRB approval, but it allows the data to be collected and allows us to do multiple experiments, but also to share it with other groups who may be interested in studying different aspects of collaboration or the educational process. So we're in the process of setting this repository up. We'd like to keep everybody posted, because this will be a way that we can then provide other people with access to at least some parts of the data to be able to use for their own research purposes. And I believe that's all the questions, and we're almost right at the end of time. So I want to just remind everybody that if you have questions, you should go to the ISAT website, which is www.isat.ai, and learn more about our institute. Feel free to also contact any of the presenters here with questions, and want to thank you all for joining in and participating in this panel. Thank you.